Hey, hello guys. In today's video, we are going to learn one of the most popular messaging framework in the .NET ecosystem, that is the MassTransit. Okay, so rather than at a simple examples, we are going to analyze a complete project containing the consumers, event, and Saga state and event-driven workflow. Okay, so by the end of this video, you will understand how messages travel through the system, what a consumer really does, how Saga coordinates multiple services, how correlation IDs keep everything synchronized, and finally, how this architecture scales in real enterprise application. Okay, so let's inspect the project. The project contains program.cs, worker.cs, and three consumers. One, it is hello consumer, and another is echo consumer, and another is a recursive consumer. Okay, so it also contains the communication state machine. Okay, so it is a core heart of the application. Okay, that manages the state and the contract to pass the messages. These are the contracts. Okay, for the echo events, hello events, and recursive event, and the events. Okay, so the events comprises of GUID and the name. Same it is replicated. Same are replicated into the hello event also and the recursive event also. Although the project uses the in-memory transport, the replacing it with RabbitMQ or Azure Service Bus requires only the configuration changes. Here we can see that, sorry, here we're configured using the in-memory it is there. So we can see that here also it is configured the Azure Service Bus. Okay, so only the connecting changes will be there, and same the RabbitMQ we can integrate. Okay, so let's look into that program.cs. Everything starts here. Mass transit is registered using dependency injection. Here, services.mass add mass transit. Okay, the project sets the set kebab case endpoint name formatter. Okay, it is basically for the communication perspective, that is the name formatter it is. So this automatically generates the endpoint names. Okay, then add consumers. This is the one, and the mass transit scan the assembly and to add the consumers there. So every consumer become automatically registers. Okay, so next it is the add Saga state machine. So this registers our Saga. Notice this line. Set in memory Saga repository provider. This one. So perfect for learning, not suitable for the production. So finally, using in memory, this replaces the RabbitMQ with an in-memory message bus. Every published message stays inside the current process. Okay. So let's look into that worker service. Okay. So worker it is registered inside the program.cs here. Add hosted service here. So whenever the application start running, so that worker service get invoked. So worker simulate an external client. Okay, so after 2 seconds, as of now it is commented for the demonstration perspective. So hello using the bus.publish, it is there. Okay, notice something important. The worker doesn't know who will receive the message. It simply publishes it. This is the publish subscribe. The sender doesn't know the receiver, and the receiver doesn't know the sender. Okay, so everything is decoupled. Okay, so now look into that hello consumer. Let's close on this one. Okay, so hello consumer listens for the hello. Okay, and when the message arrives, it logs hello. Okay, this is the one, and then publishes the hello done event. Okay, so notice it doesn't call another class directly. Instead, it publishes another event. This is the event chaining. Okay, so hello consumer finishes its job, announces I am done. Anyone interested can react. Okay, so let's look into that Saga state machine. This is the one. Okay, now comes the heart of the project, the communication state machine. It is there. Okay, a Saga is simply workflow manager. Instead of placing business logic inside one huge service, Saga remembers current state, correlation ID progress, next step, failures, retries, and imagine a project manager. Developers complete a task. The project manager decide who works next. Saga behaves exactly like that. The state machine defines hello execution state, echo execution state, and recursive execution state. Each state represents a current state of the workflow. Initially, the Saga waits for the hello done event. Okay. So when it receives it, it stores the correlation ID with respect to this. Moves to echo execution state, then it transitions to echo execution state and publishes an echo. Notice something beautiful. The Saga never executes echo itself. It simply publishes a command. Okay. Now let's look into that echo consumer. Echo consumer receives echo and it performs it works, then publishes an echo done event. Again, no direct method call. Everything happens through the message. Okay. The second state transition, the Saga listens for the I echo event, I echo done event. This is the one. When it arrives, transition to that echo execution state to recursive execution state. Then it publishes recursive again. This is what. And again, the Saga is orchestrating everything. Okay. Then a recursive consumer. Now let's look into that recursive consumer. The recursive consumer receives the recursive after the processing. It publishes a recursive done event. Saga receives it, a return to hello execution state and publishes hello again and finalize here. Saga receives it, recursive state done, and if it is done, then it publishes hello again and transitions to that hello execution state and here hello recursive. Now you you might be wondering how I am going to stop this recursive. Here I have captured, you can notice this one. Here I am forwarding that hello recursive message. Okay, and this message it is being checked here. If it that not hello recursive message, then process further. If it is hello recursive message, then finalize the job and stop the execution. Okay. So one of the most important concept here, it is the correlation ID. Imagine 1000 users all publishes hello simultaneously without correlation IDs. The Saga cannot know which echo belongs to which hello. Instead, every workflow carries the same GUID. Okay, so we can see the workflow here. Publishes hello message with the GUID, and then it's log into the message and publishes hello done event. And then communication state machine it go to that and initial event and receive the hello done event, and it transitions to that echo execution state and publish to echo message, and then echo consumer process the echo and publish to echo done event. And then once the echo done event is received in the Saga state machine, so it transitions to that recursive execution state and publish to recursive message. And the recursive consumer process the recursive message, and the it's says done with a recursive done event. Okay, this is how then the enter process goes on till the hello execution state, and the hello execution state publish the hello message and finalize the Saga. This is how the workflow it is here. Okay, now let's look into that how it works. Let's add the breakpoint in hello consumer. I have added the breakpoint here. The echo consumer added the breakpoint here, and the recursive consumer added the breakpoint here. Okay, now let's run the application. So as soon as I started the application, that worker process started here. And let's check whether it is coming here. Let's wait for its finishes. Yes. Okay, now we can see we are publishing the hello event. Okay, and now it comes to that hello consumer. Okay, now here we are checking whether that hello recursive it is received or not. So here it is the message, it is only the hello it is there. So it will loop into that this piece of code and publishes that hello done event. Okay, so now you can see that as soon as the hello done event is done, so it is publishing the echo message here. Okay, now let's go. So it comes to that echo consumer and it publishes the I echo done event. Okay, so echo done event is done. Now you can see this is the how it is binded event with echo done. Okay, and here it is execution. This state is rest and it is transitioning to that recursive execution state. Okay, now it will go to that recursive. Okay, so here it is publishing recursive event done. Okay. So when this recursive event done, so here we are transiting back to that hello execution state. Okay, and it will have the hello recursive message. Okay, so here it will jump into this loop and finalize the job. Okay, okay, you can see appropriate output we can see here. Okay, okay, so this architecture offers significant advantages. When it is the loose coupling, it is there, independent deployment, it is there, and it support for the retry, fault handling, scalability, asynchronous processing, it is there, and workflow persistent. So distributed transaction using the Saga. This is why the banks, insurance company, logistic platforms, healthcare system, and e-commerce application frequently adopts mass transit with RabbitMQ or Azure Service Bus. Okay, so you might be wondering what will change in the production. The simple use it is there. So in we will here we can see this sample uses the in-memory transport. Okay, and in-memory Saga repository it is there. Okay, so here in production you will typically replace this with the RabbitMQ, Azure Service Bus, and Amazon SQS. This is what earlier we have discussed. Okay, and we can implement the retry outbox, schedule messages, dead letter queues, and monitoring. Okay, so the business code is in the consumers, and Saga often remains unchanged. The infrastructure configuration evolves only here. Okay, so today we have learned the much more than just how to write a mass transit application. We learn how modern distribution systems communicate using messages instead of direct method calls. We explored the consumer events, publish subscribe, Saga orchestration, state transition, and correlation ID, all through the working C# example. Once you are comfortable with this concept, you will be ready to build a resilient, scalable microservice using the RabbitMQ or Azure Service Bus with Smart Transit. If you enjoyed this deep dive, don't forget to like the video, subscribe to channel, and let me know the comment which Smart Transit topic you would like to explore next. Happy coding!